Okay, this is section 4.6, and this is part 4 of a 5-part series. So you have one more video after this guy. So this one says, show that a rectangle with the largest area can be inscribed in a circle of a diameter of 10 centimeters is a square. Okay, so I know I'm looking for a rectangle with the largest area, and I know the area of a rectangle is length times width. And the hardest thing with this one is actually drawing it. So here's a circle, and if we put a rectangle inside of it, and basically ultimately I'm trying to show that this is a square. If I put the radius in, like for instance, if I put the radius across this way, that doesn't work because the ends aren't touching. So let me take that off. Maybe I can try the radius on the diagonal. That seems to work well because basically what I'm trying to do is prove that that inside rectangle is a square. So that means that the sides have to be of equal length. Okay? So I'm going to write up what I know. I know that the diameter is 10 centimeters, and I know that a rectangle or a square has right angles at every corner. So I know that. So what I can do here is I can transpose this triangle, and we can say that this is side X and this is side Y, and this is 10. Okay? And by the way, the area of a square, how I have it written out, area is right now length times width, which is going to be length X times Y. Okay? All right, so let's go back to our right triangle. The only thing that connects those sides together is Pythagorean Theorem. So we can say x squared plus y squared equals 10 squared. And basically, I need to get rid of one of those variables, either x or y, or write the variables in terms of the other to be able to use this area formula. So what I can do here is I can isolate y by writing y squared equals 100, that's what 10 squared is, minus x squared. And then I can go further to say y equals the plus or minus the square root of 100 minus x squared. The negative value doesn't make sense because once again we're talking about the length of something. So we're going to ignore the negative one and just keep the positive value of the square root of 100 minus x squared. Okay, so now let's rewrite area. Area in terms of x equals x times, now instead of writing y, I'm going to write the square root of 100 minus x squared. Now what I can do is I can rewrite this so that way I can take the derivative because that's going to be my next step. So let's rewrite this as x times 100 minus x squared raised to the 1/2 power. Unfortunately, I cannot distribute that x, so I'm going to have to use the product rule on this. So the product rule, and let me just write that a little bit more legibly. To find the derivative, to use the product rule, it's u times v prime plus v times u prime. Okay, so if I write this down, u is x, u prime is going to be 1. V is the square root of 100 minus x squared. And v prime is going to be 1/2 times 100 minus x squared raised to the negative 1/2 power. Now I got to apply the chain rule, so I got to need to multiply that by negative 2x. Okay, I got to clean that up, so let's go ahead and do that. So negative 2x over 2 is going to give me a negative x times 100 minus x squared raised to the negative 1/2 power. Okay, so let's do the product rule here. U times v prime, u is x, v prime is what we just found. So v prime is going to be negative x over the square root of 100 minus x squared. Okay. Plus, and now I'm doing v plus u prime. So what's v? V is the square root of 100 minus x squared. And then I'm going to multiply that times 1, which is u prime. Okay, so I'm at this point. I got to make this look a little better. So I get negative x squared in the numerator, because x times x is x squared, over the square root of 100 minus x squared, plus the square root of 100 minus x squared. Okay, I think it's wise at this point to find a common denominator. So your common denominator is going to be the square root of 100 minus x squared, because remember, I got to set this thing equal to 0, so it's wise to go ahead and do this. All right, so I get negative x squared over the square root of 100 minus x squared plus, now remember I have to have a common denominator, so it's 100 minus x squared, and I already have a 100 minus x squared under the square root, and now I'm going to multiply by another one to build up that fraction. So that's going to look like this, and I'm going to turn the page here. So I get negative x squared in the numerator, and then taking the square root of 100 minus x squared times another square root of 100 minus x squared gives me 100 minus x squared. And this is going to be over the square root of 100 minus x squared. Since I have negative x squared plus another negative x squared, I get negative 2x squared plus 100. And this is all over the square root of 100 minus x squared. Okay? That is the derivative of the area function. Okay, so now that I have that, I'm going to take the numerator and set it equal to 0 and solve. So negative 2x squared plus 100 equals 0. So negative 2x squared equals negative 100. X squared equals positive 50. X equals plus or minus square root of 50. Okay, so that's one of them. And by the way, once again, remember we're doing area. So negative square root of 50 is not going to make sense. So one of my critical points is going to be square root of 50. Okay, let's look at the denominator. The denominator, we're going to take a square root of 100 minus x squared, set that equal to 0. I'm going to square both sides, so I'm going to get 100 minus x squared equals 0 squared, which is just 0. And then 100 equals x squared. Take the square root of both sides, so I get plus or minus. Square root of 100 equals x. So once again, I'm only going to take the positive value because the negative one doesn't make sense. So x equals 10. So now I have another critical point, x equals 10. Okay, when I look at that, this will give me a domain problem. And the reason why it's a domain problem is because if you look back, and we'll go back there, remember the hypotenuse has to be larger than the legs. So you see right here, we had 10 as the hypotenuse. So x and y have to be smaller. That's how Pythagorean theorem works. So I can't accept x equals 10 as a critical point. Okay, so this one's a little bit tricky here. All right, so you're welcome to do one of two things. You can find the second derivative, but I guarantee you the second derivative is going to be a little bit gnarly, if you will. So I would make a sign chart for this and use test points. It might be a little bit easier to deal with. So let's go ahead and do that, and then we can figure out if we have a max. So remember, we're trying to maximize. So let's check that out. So I'm going to make a chart. Remember, my critical number is the square root of 50. So I'm going to go ahead and put that in the chart. So square root of 50 is here. Oops. And then I'm going to do a test point. And then I'm going to figure out if it's positive or negative. And then finally, what I'm going to do is I'm going to tell if the function is increasing or decreasing. Okay, so remember that when we looked at the right triangle, the max this possibly could be is 10, and the least it could be is 0, which, like I said, doesn't make sense. So I need values in between 0 and 10. So let me go ahead and use the test points of 1. So I'm going to take the function and I'm going to place it in as 1 and figure out if I have a positive or a negative value. So let's go ahead and do that over here. So the derivative of the area function at 1 is going to equal negative 2 times 1 squared plus 100 all over the square root of 100 minus 1 squared. Okay, so in the numerator, we have 100 minus 2. That's positive. In the denominator, I'm still going to have a positive value. So a positive divided by a positive is going to give me a positive. I know my function's increasing. Okay, let's check on the other side. Let's use a test point of the function at 9, because that's close to 10, right? So the area function, we're checking that out with the derivative. So the derivative of area at 9 equals negative 2 times 9 squared plus 100 all over the square root of 100 minus 9 squared. Okay. All right, guys. So 9 squared is 9 times 9, and that's going to give us 81. And then we're going to double that. So if I double that, I know my numerator is going to be negative. And once again, 9 squared is 81. So 100 minus 81, it gives me a positive underneath the square root. So basically what I have here is a negative over a positive. So I know that result's going to be negative because a negative divided by a positive is a negative. And I know that my function is decreasing there. So putting those pieces together, I know this gives me a max at that critical number of square root of 50. Okay, so remember that this was my x value. So that's the length of that triangle, right? So x is the square root of 50. Now we have to go get the y, okay? And I got to check the y. The y should be square root of 52 if the rectangle is a square. So just to remind you really quick, here's what we had. Remember x, and we had the y, and this is 10. Well, if x equals the square root of 50, then y should as well. So to solve for y, we had y isolated when we plugged it into the area formula. And remember, y equals the square root of 100 minus x squared, okay? So I'm going to find y when x equals square root of 50. So y equals 100 minus the square root of 50 squared. So the square root of 50 squared is going to give me 50. So it looks like this. We get 100 minus 50, which is the square root of 50. So we notice that these are the same. So x equals the square root of 50, which, by the way, we're in centimeters. And y also equals the square root of 50 centimeters. So since x and y are the same, we can conclude that it is a square. Okay, and this proves that it is a square.